Without further ado, I do want to go ahead and kick it off. Test with confidence, how to avoid common issues with defibrillators and AEDs. I'll go ahead and turn the presentation over to our presenters, Justin and Elliot. Take it away.
Hey, thank you very much. I am Justin Ross with Fluke Biomedical. I'm a senior technical sales engineer here at Fluke and about, I don't know, 20-some year CBET. So I worked in the field for many years before I joined the Fluke team. Your turn, Mr. Elliot.
Hi, my name's Elliot Weldon, and I'm a product application specialist here at Fluke Biomedical. I've been at Fluke for about three and a half years. And before working here at Fluke, I spent time as a biomed in a hospital here in Minnesota. And then I worked for a large OEM for 6 to 7 years working in the field. So today we're going to cover three main things here. So we're going to start with the components of a modern defibrillator. Testing has changed over time as defibrillators have advanced and capabilities have expanded. So we'll take a look at how things have changed. Next, we'll do what analyzer and equipment is needed to complete the test. So due to these changes in complexity of the devices today, we may have the need for multiple simulators and analyzers during our preventative maintenance and testing of the defibrillators. And then last, we're going to go over how can automation help manage your workflow. So how can a workflow automation tool increase the accuracy, test procedure, and documentation of the work that's being completed? Now, as a biomed, I know that if it wasn't documented, the work wasn't completed. So let's just take a look. We will take a look at how this automation can improve things for us.
Not just that, but maybe make our workflow go a little bit quicker, you know, maybe free up some time for a cup of coffee or tearing something apart.
We do know biomeds love coffee. So what we're going to do here next is we're going to throw up a question. So does your facility consider an AED a life safety device? Yes, no, or I don't know.
So this has been a really cool question. Elliot and I just did a presentation here at MD Expo a few weeks back, and this is one of the questions that got brought up, and it was kind of interesting to see what everybody had to say about it. So I'm curious to see here what you guys consider, or you all Yins, since I'm in the Northeast, Yinsers, or consider, is it a life safety device?
And that first poll question has been launched and responses are coming in. We're going to give attendees about 30 more seconds to enter their response, and then I'll close the poll. So thanks for that. Yeah, this is a really great question.
What do you think, Elliot? What do you think the percent is going to be that say yes?
I think maybe, I don't know, we've seen different opinions on this, so I'm going to go with just 50-50 because I'm not sure where the crowd stands on this.
All right, that's a good guess. That puts us in the ballpark. All right.
Wow. Okay, you got to be surprised, Elliot. And that poll is now closing, and I will share the results.
Oh!
Wow.
Okay.
Yeah, 95% of the audience said yes. 4% indicated no, and the additional 2% indicated I don't know. Interesting results.
Elliot, that sounds like you owe me a cup of coffee when we get to Amy.
I think I do, yeah. So we're going to roll this into a second question here. Does your facility consider a defibrillator a life safety device? And not just an AED, but just a full defibrillator, which I think we're going to know the answer.
Yeah, man, you could probably double down on this one.
Yeah.
But watch out, this is one where somebody comes back and just slams us, then we get thrown off for a loop.
And the responses for this question that's coming in. And once again, we'll give participants about 30 seconds to enter their response. And thanks to the audience for your participation in our poll questions. This is very, very helpful for us as we're developing our webinars. So thank you.
Yeah, this is really cool because, you know, we had this discussion. We've had this discussion with a lot of our customers. You know, Elliot and I travel around the nation and work with different customers and show them, well, I guess around the world, travel around the world and show people how to get the most out of their Fluke devices. And this question comes up a lot about how they're testing and how they're building out their PM procedures. And so with that, we'll see what the results are here.
Okay, you're ready. I'm going to close the poll now and share those results. So 89% of the audience said yes, 6% said no, and I don't know.
Oh, good ones.
Yeah.
Elliot, I don't remember if you're supposed to come up on this or if this was me, so I'll let you go first.
Well, it's just a little interesting because if I'm looking at this correctly, we have more people saying that the AED life safety device is considered at a higher, more people perceive that as a life safety device over the defibrillator. It's very close though.
Yeah, it is really close. And the reason I wanted to bring this up, or we wanted to bring this question up, is we do have a lot of facilities that say that AED is not a life safety device. We have other ones who say that the defibrillator is not a life safety device. And the argument for some of these facilities is, well, hey, listen, we're not saving a patient. The patient's already dead. So we're just trying to bring him back to life. And they've actually removed it from their EM. I'm not saying that's right or not, but then I had a customer come back to me the other day and this with the same topic and said, well, hey, if that defibrillator has a pacemaker, that pacemaker is only used on living patients, so it'd have to be a life safety device. So for everybody who's looking at these two questions and looking at your PM protocols and your scheduling, just an interesting question to think about. And if you happen to be at Amy and swing by the Fluke booth, let's have a conversation about it because I'd really love to hear your input on that. So with that, let's talk about what defibrillators are used for. So there are two main categories of heart issues, mechanical issues and electrical issues. We'll just break this right down to our basic biomed 101 here. So mechanical issues can lead into electrical issues. Some mechanical issues, like you could have a bad heart valve, the muscle could have something wrong in it. You could have blood loss where the blood is not pumping correctly, or you could have a clogged valve, clogged line, causing it not to pump, the heart not to pump correctly. And that can lead into electrical issues. Now, the reason we need to know this is because defibrillators can only treat the electrical issues. So while you might send a patient to VFib or VTAC or any one of these arrhythmias out there, and there's a lot of them, we can only treat those electrical issues. But if the mechanical issues aren't fixed, even if we treat that electrical issue, that heart can go right back into that arrhythmia. So something to note, I don't know if there's any first responders or CPR providers out there in the audience today, but keep that into consideration that even though we might treat somebody, if we don't fix that mechanical issue, it's going to go right back into it. So again, our defibs are going to focus on those electrical issues and those arrhythmias. So I didn't advance myself.
So, defibrillators perform critical jobs, and the main goal of this of defibrillators is to save lives and increase survival rate. Defibrillators deliver a shock to a patient to convert their heart back into a normal rhythm. And even certain defibrillators not only have the ability to deliver this shock or energy to a patient, but also have the ability to pace a patient. And with that too, this is kind of rolls into our next slide, but most defibrillators also have the ability to obtain important patient vitals, and that's even more important when you get into the certain environments where you don't have a full operating room full of equipment. So if we look at this slide here, we've kind of broken down our types of defibrillators into three types: AEDs, clinical defibrillators, and then transport. So our AEDs are going to be the ones that first responder units and basic life support, or AEDs that are going to be found in public places. So if you go to the gym or maybe church, you're going to most likely see an AED on the wall somewhere that's mainly used by untrained people to help a person in a cardiac episode. And these kind of can walk you through and assist an untrained person to assist in a cardiac episode until maybe the professionals get there. Clinical defibrillators are going to be more found on patient floors. Typically, these have more features built into them as they're used by the trained personnel. And these are going to have maybe more parameters on them, being able to do, pacing and maybe checking more parameters, like, you know, SpO2, ECG, NIBP. So they're going to have, you know, kind of a patient monitor built to them. And then we have transports, which are like very compact, usually compact devices that have all the modalities of patient testing. These are used in, you know, again, non-clinical environments, maybe like in a helicopter or a an ambulance. So those are going to be the ones that are going to have most of the functions, you know, that you'd find on a not only on a, you know, defibrillator, but also on like a big patient monitor that you'd find maybe in the, you know, the ICU or the OR.
Yeah, those can get to be a lot. You know, those ALS units, advanced life support units, you know, you might have a full-blown step-down monitor on that thing. And some of these defibs, we kind of put these in these three nice little classifications, but there's some bleed over in between them, you know. A lot of these clinical AEDs now, or clinical defibrillators, they'll have an AED mode in it or an advisory mode in it. Some of the ALS units have the same way, where you can function as an AED and then switch it over. So if you look at the defibrillator, there's three main components built into a defibrillator, a modern defibrillator. And we went back through the archives, and I remember this picture, and I want to pull this picture back. So if you look at this picture, this is a really cool picture of the defibrillator. I remember working on these. That's how old I am, unfortunately. But if you look at this unit, you'll see that the defibrillator and then the patient monitors on the left, those two pieces came apart. So you can actually just carry the patient monitor side, or you could carry the defibrillator side. But if you want to do a cardiovert, like, you had to slide them together. And then on the very top of that black box with the knob on it, that was the pacer, and it was an option. You could buy the defibrillator with the monitor, and then you could buy the pacer later on, and it slid down into the top. So the old school ones would literally just say defibrillator. And then I remember working on like the LifePak 9s that said monitor defibrillator. And then there's LifePak 9Ps or monitor defibrillator pacemaker. So when we're talking about a monitor defibrillator, you're actually not just having one device. You could actually have three devices all built into that box. And that's something really important to remember, because as you're testing it, you're going to have to test all three of those sections. There's other things that might be built into that we didn't even talk about yet, like a transthoracic impedance monitor. We'll talk a little bit more about that here in a minute. How about data communications and data recording? You know, a lot of these AEDs and these defibrillators, they're going to record everything that's going on, not just the ECG strips, but a lot of them have microphones, and they're recording what's going on in the background. Some of them you can tag in drug libraries into them. Additional features, battery maintenance. That's another thing we're talking about a little bit more here in the future, and some more slides. But some defibrillators, you can't just plug into the wall and charge them every time. You got to take that battery out and go take it down to a docking station and wipe the battery memory out and reprogram it. And then another feature that gets overlooked a lot is CPR pressure and rate monitors. So you might see these new pads, and on that pad, it has a place where you're going to put your hands. It's going to show you right where to put your hands, and it's going to tell you if you're depressing deep enough into the patient to perform good CPR. And now another little hint, do you have the right protocol for your CPR in your AED or defibrillator? And again, we'll bounce on that here a little bit more. So what is a defibrillator used for? Let's break this down. Let's start talking about these three sections. What's that defibrillator used for? Oxford language says a defibrillator is an apparatus used to control heart fibrillation by application of electrical current to the chest wall or heart. Yeah, that means we're getting zapped. That's how we're going to treat the patient. So some of those functions, again, that AED mode or advisory mode, you might hear cardioversion, where we're going to have an abnormal heart rhythm, and we're going to try to shock the heart at an exact precise period in that in the sinus waveform to cause it to get back into rhythm. So that's a very specific test, that cardioversion test. And then again, we talked about just the defibrillation, where we're going to return that heart from any arrhythmia back to that normal sinus rhythm. And that's going to lead us into some of the components of the patient monitor portion of it. Mr. E?
So the patient monitor portion of the defibrillator, you know, again, it it can change what's on the defibrillator based on how that defibrillator is being used, or maybe where it's being used. So we have listed here just you know, the parameters that typically can be found on a defibrillator that is part of the patient monitor. So we have ECG, which can be up to, you know, a 12-lead ECG, but I think, you know, most of the ones that I've seen in the hospital, and maybe you've seen too, are usually, you know, 3 or 5-lead ECGs. We also have NIBP, non-invasive blood pressure, IBP, patient temperature, of course, and then SpO2. So some of the SpO2 sensors, maybe especially in, you know, you know, helicopters or ambulances, are going to have that have a Massimo rainbow, which allows you to test more parameters like SPMet, SpHg, and EtCO2. So just keep in mind when you're doing your maintenance or looking at your inventory that if your devices do have those capabilities, that you might need some sort of tool, or you'll need a patient simulator tool that can handle that Massimo rainbow SpO2 lead. And then just, you know, with the modern defibrillators, obviously we'll need to use a defibrillator analyzer, but because there are you know, these different you know, these 3 really devices that are working on the device, you might also need other test tools, maybe something that can measure flow, or of course patient monitor simulators. So with that, we're gonna talk about the transcutaneous pacemaker.
Hey, Elliot, before we jump to that slide though, let me talk about one more thing. We mentioned non-invasive blood pressure, and that's great, but something that just came up a few years ago, we've always checked non-invasive blood pressure in descending. So we pump it up to like 165 millimeters of mercury and bleed down our pressure. And so we check it systolic over diastolic, right? But if you see, some of the new defibrillators now have rapid NIBP, where it's doing it in reverse. So it's going to check your diastolic first and then catch your systolic at the top side. So it's something to consider, because not all patient simulators out there can actually catch that ascending NIBP versus the descending. Now, something good to know, remember though, when we're checking NIBP, we're going to do that at a static pressure, right? We're not going to check it on the dynamic pressure. It's going to be a static check. But we always want to run 1 or 2 simulations just to make sure it's going to catch. So if your simulator can't do that, a lot of these defibrillators then who do have the ascending NIBP can flip over and also read descending. So just something really to note. And I love that Massimo rainbow technology. I'm living up in the northeastern United States. A lot of our homes are heated with natural gas. So we have a lot of carbon monoxide victims up here. And this has really been a big help as we using defibrillators on patients. I should also mention I'm a volunteer firefighter, so that's another place we use this Massimo rainbow technology, is checking on firefighters who might have smoke inhalation. So great technology, but something that's hidden in a lot of defibrillators that some people overlook. So do me a favor, if you have any of these advanced defibs out there, check and see if it's just Massimo or if it's the Massimo rainbow technology, and then see if you have the appropriate tools to test that. So, okay, sorry, man, I got a little bit off there. Happens with me a lot. Transcutaneous pacemakers. So, oh, this one's yours too. Sorry, man.
I don't. Okay.
Oh, nope, you're right. It's mine. So transcutaneous pacemakers. Real quick, there's 2 kinds of pacemakers that we see a lot. There's transvenous pacemakers, the ones that are going to have leads implanted into your heart or into the vein. These are transcutaneous. These are the ones you find in a defibrillator, meaning it's going to go in across the external patient's chest, so across the skin. Transcutaneous pacemakers, according to Medicine.net, transcutaneous cardiac pacing, TCP, temporarily paces a patient's heart during an emergency and stabilizes them. You can read the rest of this, but transcutaneous cardiac pacing or non-invasive and temporary means of pacing a patient's heart during an emergency and stabilizing them until a better intervention is achieved. So if you have a patient who has a low heart rate, this is going to get them up to like a bradycardia rhythm. This is going to get them up to a higher higher heart rate. These are typically single channel devices. the reason I want to point this out, there are dual channel pacemakers out there. Again, those are things you'll find in like a cath lab or in an ER, not the ones on a defibrillator. So if you're using a defibrillator analyzer, for instance, like the Fluke Impulse 7000, it has a built-in single channel transcutaneous pacemaker analyzer. Again, single channel across the chest, the kind are built into defibs. It cannot test the dual channels, the ones that are implanted that have the ventricle and aortic pacemaking. So a little bit of a difference there. Make sure you have the right device, right test for the right application. So what can go wrong with all these devices? There's some general categories here: internal component failures, battery or pad failure, non-compatible pad connections. Hey, this happens a lot. And you're going to say, well, how is this my responsibility? So as a biomed, we want to make sure that patients have the best experience possible, right? The best outcome. So what can happen here with these pad connections is if you have an AED out there, right? You don't control the AEDs. They're at shopping malls. They might be in the back of a cop car or in a fire truck or wherever that AED is at. Somebody else bought that AED. Now you have a first response, you might have an ambulance. So when that ambulance shows up to take care of that patient, you know, the general citizen uses the AED and it has one style. Well, now the medic shows up and they're going to use their defibrillator with its built-in AED. And all of a sudden those pads aren't interchangeable. So you got to rip the first set of pads off the patient's chest and put a second set of pads on. It can happen again when you go to put that patient onto a helicopter to transport them in an emergency situation where the helicopter doesn't have the same pads as the ambulance does. And then you get to the hospital, and do they have even yet another set? Because some of these helicopters respond to multiple hospitals. So different hospitals, different defibrillators. So that pad compatibility and connections could be a big deal. So if you happen to be tasked as a biomed to advise on defibrillators, that's one of the questions we'd like to ask. Does ours marry with our local first responders? And then let's get down here to this operator error, and we'll go back up to the top. So operator error, I just had to redo my CPR class the other day. And when I redid my CPR, we're talking about AEDs and training. So a lot of the AEDs would say we're going to shock the patient. Well, people get freaked out because the patient's already in a bad situation. Now it's saying to shock them, and they don't want to do any additional harm. So some people might remember some AEDs now say treat the patient versus shock the patient. So is our general public trained? So because sometimes these failures that we're seeing might not be an actual internal component failure, but a setup or training failure. And it just doesn't happen with your average citizen. This is also hospital employees. How often do your hospital employees, your clinicians, actually discharge a defibrillator? Are they familiar with saying the word shock and knowing that it's not going to hurt the patient? I like to bring this up because as we're recording our outputs and our information from the defibrillator, well, everything might look okay on our paper. In our CMMS systems, are we tracking our failure codes? And one of the ones that might turn up is an operator error. And this is one of those ones that's easy to address. We can go out and we can talk to people and the staffs and use our defibrillator analyzers and our simulators to show them that it's doing its job and working through it. Before we move on, let's go back up to the top to the internal component failures. So again, I mentioned I'm a firefighter. I know where my AED is. My AED on my fire truck is in the first compartment on the officer's side. I live in Pennsylvania. In Pennsylvania, it gets about -20 degrees Fahrenheit in the wintertime. That AED rides around in that front compartment of my fire truck in the middle of wintertime. It gets to be -20 degrees and it gets cold. And then it goes back into the fire station where it's 50 degrees. In the summertime, we get stuck out on these fire calls, these extended fire calls. And inside that compartment, which is up against our pump, gets really hot. So that defibrillator or that AED isn't exposed to normal operating temperatures like you might find in a hospital. So these AEDs and defibs, they might be exposed to these extremes. Here's another thing: the ones on the helicopters or on the ambulances, those are going into accident scenes. Accident scenes aren't always nice, warm, dry places. Sometimes it's sopping wet and pouring down rain. These machines can be exposed to all kinds of environmental conditions, even the ones in your hospital. Think about this. What do we use to clean our devices with? Cavi wipes, caustic chemicals, cleaning solutions, Clorox. All those things could deteriorate the outside casings of these defibs. They could have long-lasting consequences. So please, when you're doing these things, take the time and make sure that we're going through the defibs and through the PMs, because we want to make sure this device works the first time every time. So while some people might only do a visual inspection, make sure it's a good, thorough visual inspection of that AED. We mentioned battery and or pad failures here. I don't see this as much anymore as we used to, but people want to have that defib ready to go. So what they do is they take their AED pads and open them up, right? So they can be plugged in. Well, as soon as you open up those AED pads, they're going to start to dry out. So just another consideration there. You know, why might not be a mechanical failure with the defib as you're doing your PM circulation and you're looking at these machines? Are you seeing these other environmental conditions that might deteriorate the life of your defibrillator? I'm sure I went well over my time on that slide, Elliot. My apologies.
No worries, no worries. So we'll take a look here at the test requirements that are used to, you know, by associations and associations and organizations that, you know, help make up the tests that we're running. So the first one here is the FDA, or the Ministries of Health, and they approve defibrillator designs that can be sold in the U.S. or specific countries. You know, mainly for the Ministries of Health, based on the test data collected using tools like, you know, the Impulse 7000, based on when following the test in the local, by the local standards for the defibs, and the national standards by the defibs, pacemakers, and monitors. Next up, we have the international national standards like IEC and ANSI. And these are going to specify what must be tested and how these parameters should be tested when evaluating the safety and effectiveness of the medical device design. Next, we have the manufacturer specifications. So these are going to be the manufacturers of the defibrillators, and they're going to come out with recommendations on what should be tested on their products, how often they should be tested. Usually you see, I know when I was a biomed, we would do our PMs on our defibrillators twice yearly. But as we see, you know, defibrillators getting, you know, more modernized and advanced, some of the OEMs are calling for less frequency of testing, maybe once a year. And again, that's whether you follow that or not. I mean, that's kind of up to your hospital too. Just keep in mind that things maybe have changed on your newer defibrillators. And then the last one here we have is accreditations of healthcare facilities. So these are going to be like local groups that accredit hospitals in your local area. We're all familiar with, you know, Joint Commission, but then we have other ones like DNV, HFAP, and ACA, and these are again accrediting institutions that give accredits to hospitals, and that includes the biomed department. So I mean, again, I know we're all aware of the Joint Commission when they come into town. With that, the medical device testing in your frequency can also be based on your hospital's policies and procedures, and that's based off maybe like a risk score or medical device management plan. So next up, we have a question. Unless there's anything you wanted to add there, Justin.
No way, man. I've talked a lot.
Okay, so we have a poll question here. Do you know your body's transthoracic impedance at this moment? And yep, so we'll throw that up. Yes, no, or what is transthoracic impedance?
We assume in the medical world that every patient is a 30-some-year-old male patient with 50 ohms resistance across their chest. I myself am a 245-pound hairy woolly mammoth. I guarantee you there's not 50 ohms resistance across my chest. It's not even on my best day.
And that poll question has been launched, and we'll give participants about another 25 seconds to enter their response, because I know we have quite a bit of other additional information that Elliot, I know you and Justin would like to share. So let's see, about 70% of the audience has voted. And we're going to go ahead and close the poll question. And thanks for everyone for your participation in our 3 poll questions today. And I'll share those results. So let's see, 72% of the audience said no, 13% indicated yes, and the additional 15% indicated what is it?
Ellie, we should have had a follow-up question. For the 13% said yes, how many are sitting there with a multimeter on their chest right now? Just
yeah,
curious.
I'm a little surprised that 13%. You know that I definitely don't know mine, but you know, I'm a bigger guy too, so I mean I'm gonna have probably a little bit higher impedance level than your average size male. But you know, for this, there's really no right or wrong answer. You know, most people really don't know this, but you know, the good news is that modern defibrillators have a sensing functionality for impedance that allows the defib to adjust the output energy to match the patient's size. But we want to think about that because when we do our testing on the devices, you know, certain defibrillator analyzers usually have or could only maybe have one specific impedance setting, but then there are, you know, here at Fluke, we do have a multiple test load tool, a 7010 load box that allows you to mimic patients, you know, very small, you know, infants up to, you know, larger adults. So it's something to think about when you think about what is your hospital typically, what's, you know, is it a hospital for children or is it an adult hospital? Because then maybe, you know, you can decide whether you should be using a multiple test load to do your testing.
That's a good point, Elliot. You know, we'll start talking about defibrillation efficacy here. So we'll advance to the next slide where we're talking about children. I work with a bunch of children's hospitals, and they like to point out that, you know, a lot of medical equipment is not designed for children's or pediatrics. It's designed for adults and then adapted to children and pediatrics. So that could be a very drastic swing. And what we really want to ensure is if we set that defibrillator at whatever joule, call it 100 joules, right? And I attach it to a brand new baby who needs it, that they're getting that 100 joules. Just as easily if you attach it to myself or a geriatric patient or bariatric patient, those are all drastically different resistances. And we set it to 100 joules. Is that patient also getting the 100 joules? So we have to ensure this defibrillator efficacy where we want to make sure that the required amount of energy is delivered to the heart over the effective time period. So we're going to get this conductivity to the patient and it's going to actually do its job the first time. Things that play into this is body mass, skin resistance, tissue type. Here's another one. Does anybody use moisturizer? Are you hairy? You know, I am a swimmer. I swim a lot, so I'm in chlorine water, so my skin typically is dry. All these things have big factors on this efficacy and what our transthoracic impedance is. Here's some other things we talked about. Remember, not every patient has their heart attack or has their issue in the clinic. These are usually out and about. Are they in a swimming pool? Are they wet? Is it an accident scene? Are there fluids on them like oils? You know, there's a lot of other things that could play into effect here that need to be thought about to make sure that patient is getting that correct value. So let's move to the next one. We're going to talk about testing for various impedance values. So we want to consider what's the history of the equipment. You know, when was it built? How is it designed? What's it supposed to be doing? Really look at how that defibrillator is supposed to be performing its job. Is there a protocol in place stating that you should be doing this? Specific times we should definitely be testing at these different values is anytime we're doing an incoming inspection. So anytime I have a brand new defib, I want to make sure that each and everything in that defibrillator is working exactly the way it should. And if you look in the service manuals, this is another challenge. Do you have the right version service manual? I'm here to tell you, I work on some of these defibs and they're on like revision M or R. So A through R have been different revisions. You might find that there's a chart at the end of the discharge test that lists out the different resistances they want you to discharge at and what you should read as the joule output. So incoming inspections, for sure, I definitely want to test then. And anytime I'm doing a repair to the charging circuit. So if we're still some of these shops like to tear it into equipment and troubleshoot things, if I'm putting it back together, you really should think about going the whole way through and doing all those resistance output testing. Wow. Another one, anytime we fail to deliver the appropriate energy. So if we get a complaint from the doc or from a clinician saying, hey, we set this defibrillator here, we don't feel like it discharged appropriately, or on a strip, a lot of the strips will say what the actual joule output discharge was. If it's not looking like where it should be and they call a complaint, that's another great time to go through and test this entire spectrum. And the spectrum usually runs from around 25 ohms up to about 200 ohms. So this is all in accordance to the IEC 60601-2-4 standard, or the AMI-DF 80 standards. So that's where the back end of this test is. So what does this device look like? Let's roll into the next slide here. This is a solution. This just happens to be Fluke Solution. This is an addition to your defib analyzer. It's going to sit below it. It's going to connect to it, and it's going to allow you to select these different resistances. If you've not used one of these defibrillator the load boxes before, get a hold of your Fluke rep or go into Advantage Training. There's some things you have to be considering. You have to set up your defib analyzer so that it can accept these loads. So things to keep in mind there. If you're going to use one and you haven't used it before, pull up the manual, go to Advantage Training or call your rep and make sure that you have it set up correctly so that you're getting the correct readings. Well, that's a lot of information. And there's a lot of things to think about testing on a defibrillator. So that's a lot of analyzers, Elliot.
Yeah. So like we talked about, right? The modern defibrillator kind of has, again, like 3 different pieces of medical equipment in them: defibrillator, patient monitor, and potentially a pacer. So we're going to need something that can test the functionality of this device. So on the right side of the screen, we have just Fluke Biomedical solutions. They're not the only solution, but these are the solutions that we have for testing defibrillators. Now, testing for the defibrillation on a defibrillator, we might need to test energy output, max charge time, disarming, being able to discharge internally if you need to do that on the defibrillator, discharge the waveform, and cardioversion time sync, which could be done with the defibrillator analyzers that we have here at Fluke, the Impulse 6000 and 7000. We also have in the picture on the right side the 7010 load box, which is going to be used on the 7000 DP specifically. So we have a few other, we have the patient monitor and the pacemaker. So for patient monitor, we need to test all the parameters and the high and low alarms. You can do that with the ProSim 8 listed on the right side of the screen. Just keep in mind, again, you might have Massimo Rainbow on your devices, which you can test with the ProSim 8. And with testing ETCO2, you might need a flow meter to do that test, or calibration gas. And then lastly, we have the transcutaneous pacemaker, which we might need to test rate, amplitude, sync pacing, asynchronous pacing, or possible refractory period. And you can do that also with the 7000 DP. You might want to take a look at, accessories that might need to be purchased or used with your testing, because not all defibrillators have the same accessories. So just whatever solution you're using, just to make sure you have the correct accessories for doing your testing. There's a couple additional features that need to be tested, and it's your battery maintenance, your AED advisory mode, and your data recording. So these solutions that we have listed here can help with all of this. But with that,
Hey, I'll throw one more in there, Elliot. One more other consideration. If we're looking at these different loads and doing some of these different tests, some of the manuals will actually call for you to look at the discharge waveform to make sure it's actually producing the appropriate waveform, like a Lown waveform. So if it's a monopolar, make sure that the discharge waveform looks correct. So a nice feature about that DP7000 is on the back side of it, there's an oscilloscope port. So believe it or not, we might even need to bring out an oscilloscope out of the closet. We haven't used those probably in a while. Might have to take a little bit to figure out how to set them up. But you might also need an oscilloscope to look at the waveform, especially if you're trying to troubleshoot one of these defibs or look at that waveform. Sorry, man, I just had to toss that one in there. I love my oscilloscope.
I missed that one, so. With all these tools that we're talking about, there is a solution or an opportunity to use automation to speed up the process and make sure that we're doing the correct testing, each and every time. So we have here at Fluke Biomedical is a workflow automation tool, and what this does is it allows for standardized procedures to be ran using multiple test tools at once. So it's not just using your defibrillator analyzer, but it's using your whole gambit of hardware within your procedure. And with this, you can standardize your test based on the model specific. So if you're using, if you're using a defibrillator that's standardized across the hospital, there might be certain models or features that are on one device that aren't on the other. Take, for instance, in the ICU, there might be, a defibrillator that has all the parameters, and then in other areas of the hospital, it might only have one or two patient monitor parameters. So being able to just standardize to make sure you're doing the right tests on the right device, that's a feature here. And of course, also time savings. So you can automate the data flow directly from the hardware directly into the procedure or checklist that you're using, which can reduce human error or missteps by controlling like the mandatory steps, or just being able to pull the data in directly from the hardware. I myself have horrible handwriting, and I can't. There's been more than a few times where I've written down things in my notebook when I was doing biomed testing, and then got back to my desk to record this information and couldn't necessarily read my numbers, so I had to go back and do the test. With this workflow automation, of course, documenting is a huge thing, like we talked about earlier. If it's not documented, it wasn't completed. So integrating into your CMMS to save time to get the test information in there from your defibrillator testing can just save you a lot of time, and again, just minimize errors. So with this automation tool, it's not just specific to your defibrillator testing. That's just kind of what we're talking about today. But it's just to standardize the work that's being performed throughout your testing. That's kind of how the workflow automation tool works. And next we have a video completed. Yeah.
Hey, I wanted to throw one thing in there. You mentioned about the different models of defibrillators and how they can have some difference in the parameters. I just saw this last week. I was at a facility up in New England, and they've been running the ZOL-R defibrillators, and the facility went ahead and bought ZOL-R pluses, and they're going to start integrating some of the ZOL-R pluses. And the big difference between the ZOL-R and ZOL-R plus is their plus has non-invasive blood pressure. So while all their ZOL-Rs have had ECG, 3-lead and 5-lead ECG, now some of their defibs are going to have non-invasive blood pressure. So unless you really look at the defib close, you might not see that NIBP port. So this is a great feature here where they can log this in, so it'll show you, hey, this one for sure has these features and this one doesn't. So just great key, and that just happened to happen last week. And as we go into this video, I know we're pushing time here a little bit. So if you have questions, please feel free to start dropping them in the chat. And when we're done with the video, we're going to start addressing those, but that way we can get through as many people's questions as possible. So at that, Mr. Dan. We'll turn this video on. I'm going to show you how to get the most out of your defib testing experience utilizing Fluke Biomedical OneQA workflow automation software. OneQA comes with over 63 pre-built work order procedures.
But we recommend that you please review those procedures before you adopt them. Make sure it meets all your hospital's policies and procedures, as well as meets the most recent version of the OEM equipment's service manual. Let's get cracking into work order, and we'll show you how to get the most out of your testing experience with reliability and repeatability, as well as easy, accurate ways to record your data. Please note what we're about to show you is not a standard preventive maintenance procedure. This is something we made up for demonstration purposes only. Getting into the work order here, we have two different preventive maintenance procedures we can select. We will select this one for right now. And here's all the information we need to know, as well as the work order ID. Moving on, we're going to be doing a preventive maintenance style work order and the device we're going to be testing, as well as all the information from the analyzers that are connected to the OneQA software at this point. In these sections, you can start to customize special notes. Maybe everything that you're going to do for your preventive maintenance procedure, or any special equipment that you need to bring along with you, as well as access codes. All that can be recorded right here into OneQA. Moving down to a physical inspection of the unit, this is actually one of the steps. So we'd simply read the instructions and then select either pass for this one, and maybe for this one we'll read this instruction and pass for here. And then in this case, what if it fails? So here you have a green light go, here red stop, there's an issue. So now we can either go back and correct the issue and make this a pass, or we can leave it as fail and complete the work under conditions. Moving on to the next step. Here's what we're going to need to do the electrical safety test. Instead of having to read a diagram though, we can actually insert a picture of how to do the connections. So here it is, my 1 to 10 adapter block, my hands-free adapter. So I've connected my entire defibrillator at one time to the safety analyzer. Here's the test we're going to perform, as well as any special instructions. And now here's a diagram that corresponds to the picture we just showed you, so we can double check our work. And now getting into the test, I simply push play, follow the instructions, turn my defibrillator on, hit continue. All right, now I'd like to power my defibrillator off, hit continue. And you'll notice that my electrical safety results have automatically been recorded. I didn't have to remember how to set up or operate my safety analyzer. I didn't even have to bring in any of the data. It did it for me automatically. Everything was already done for me there. So moving on to the next tests. Here are some operational tests. And what we did here is I actually cut and pasted right out of the service manual into OneQA. So I have the exact diagrams and button pushes to get to the keypad test that would look like this. Simply follow the instructions, and I would hit pass when I'm done with it. Or if there's an issue, fail, obviously. Moving on to a shock test, we can show you how to use the defibrillator, the Impulse 7000. Here's a picture of how to connect it. In the case of the Zoll X series manual, we need to use the additional 7010 load blocks and use different loads to discharge our defib at. So we'll follow the instructions. Right there it shows at 25 ohms. Everything else is connected correct. Oh, here we go. Move my cables down. There we go. So that's here. These are here. And these are here. Good to go. Now we'll simply turn on our defibrillator. Follow the instructions. Go to here. We're at 25 ohms. Select 50 joules on my defibrillator. Charge. Discharge. There's my results. 50 ohms. Charge. Discharge. And one last time at 175 ohms. Charge. Discharge. Go shut my defib off and select done. It's that easy. It makes sure that you complete all your steps, that all your data is accurate, and that nothing was missed. This way, it just makes the whole job and the whole experience of testing defibrillators so much easier. Thank you very much, and we'll see you in the next video.
I got to say, the guy in that video is a pretty good looking guy. Yep.
Yeah, he is.
And the
Great,
first
thank you,
question.
Justin. Yeah, great. Thank you, Justin and Elliot. Great presentation today. Again, I want to remind folks, if you do have questions, use the questions option in GoToWebinar and send them our way. But with that, let's jump into some questions that have come in. And I'm going to start with this one, Justin. Is there a specific requirement to show documentation that all tests are done under battery power, AC, and AC power?
I don't know that there actually is a specific document saying it. That's always just been one of those great test practices. I'd have to probably go back and look in the IEC standards, but it's always been a great practice because you know what? Remember we mentioned we never know how long those batteries last. I'll give you an example. There's an AED, an older AED, that the battery is actually good for 300 some discharges at max joules, and people never knew where in that 300 they were. And you remember some of the batteries are like lithium-ion batteries now. And if anybody's a power tool user, how sometimes you have power, and all of a sudden it dies. I like testing under both situations because I want to make sure that defib works in every situation it could possibly be needed. So if it's going to be on battery, I need to make sure it's going to work on battery and have the full range. If it's going to be plugged into the wall because the battery's dead, I need to make sure it's going to do that too and that it's charging the battery. So while I don't know there's a specific documentation, man, best practice, yes, for sure. Make sure both sides work, please.
Great, thank you, Justin. I have a few more questions that have rolled in. Going back to OneQA, does it drive all the test devices?
Yeah, the Fluke Biomedical, you know, we have our line of Fluke Biomedical hardware, and it drives all of the modalities except for one currently, which is not. But I mean, as far as your electrical safety analyzers, is, you know, 6, 12, 14, 15, 20, your the VTs analyzers, the impulses, the ProSim 8, the Ray Safe tool. Yeah, it drives most of our analyzers currently. I think I got them all, Justin, correct?
Yeah, you know what? And the other part is even if it doesn't drive it for some reason, like we have one that we're still working on building right now, or you might have a competitions device, you can still get benefits of OneQA because you can build into that OneQA how to do the test and put a picture in it, how to hook it up, and you can even build the tolerances in it. So if I have to grab a competitive device, I can still use that procedure and it's going to record that tolerance, and you know, I'm going to write the tolerance in and it's going to tell me if it's passing or not. So there's still great benefits to OneQA.
Great, thank you, Elliot and Justin. Next question here. I have a customer that's asking the difference between the 6000D and the 7000 DP that Fluke Biomedical has to offer.
So the 7000 DP, the biggest difference is like we talked about it in the earlier in the webinar, is the ability to use that 7010 load box. So that's a big difference. And then testing the external pacemakers. So if those are two things that you're wanting to do with your defibrillator analyzer, then the 7000 DP would be you know, maybe the one to look at. Both are great tools though.
Great, thank you, Elliot. And Elliot, we have a couple questions here. Just it sounds like some of the folks, you know, want to learn a little bit more about OneQA, and I'll get a link out to the folks that are asking for a link to try it. But can you give a little background on, you know, the trial and what they'll have to, you know, how OneQA is set up?
Yeah, definitely. So there is you know, a link on our website that allows you to go in and, you know, look at OneQA, familiarize yourself with it. But then if you did want to move into a trial, there is a 60-day free trial for anybody that wants to try it. It's on the Fluke Biomedical page. Right, I believe right at the top where it says, you know, get your free trial. That allows you to use the tool for 60 days. We have a local channel team out there that you're probably all familiar with in your local area. that can assist with questions. And then once you sign up, someone will probably reach out to you too to answer any questions that you have. But yeah, definitely, you know, start with the 60-day trial and you know, familiarize yourself, and definitely we're here to help you if you have any questions on that tool.
Great, thank you, Elliot. There's one more question here. How do I test dual channel pacemakers with the Impulse 7000?
Well, I'll grab that one. And that's a great question. I get that one a lot. And the unfortunate answer is you can't. You can't. You really, the dual channel pacemakers require a different analyzer. The defib, the Impulse 7000 is only built to do the single channel. So while people try to adapt it over, it's not going to work right for you. So you really do need to get a separate analyzer for that dual channel pacemaker, for sure. What was the last question? Does your wife actually know you have a defibrillator in your office? No, I don't have it anymore. I had to give it back.
Well, that is all the questions. You know, before we close out, I do want to remind everyone, you know, we have our Advantage Training option on the website. Just go to flukebiomedical.com, Knowledge Center and Training, and register for that Advantage Training program. It has, you know, self-paced free training, quizzes, white papers, app notes, videos, ROI calculators. It's absolutely free. So I do encourage you to, you know, continue your learning and get involved with the Advantage Training program. With that, that is all of our questions. Elliot and Justin, do you guys have anything else to add before we call it for the webinar?
You know what? Hey, thanks everybody for your time. It was great hanging out with you. I hope to see you all again at the next webinar. And if not, you know, try to find us at the next local trade show. We'll see you soon.
Thank you.